Good morning. This is your Stat Sensei, Mr. Spensei, and this is the want some candy scenario. You'll have to look at your exit ticket to get the problem. And it says a candy machine is supposed to fill bags of candy with an average of 19.25 ounces. So that's kind of like that's my claim. So I'm going to write that up. Mu is 19.25. That's what they say is putting in the bag. The machine has a standard deviation of zero point 0.1. Um, uh, um, excuse me, let's scratch that part out. A random sample of 32 bags out of a batch of 5,000 had an average weight of 19.22. So we have a sample size of 32 um, out of a population of 5,000. And the average weight of the sample was X bar is 19.22. And it had a sample, this says sample mean, it should say sample standard deviation. I'll need to make that correction. Sample standard deviation of 0.1. So S equals 0.1. Create a 95% confidence interval for the actual amount of candy in the bag. All right, so we're going to be running a t-test because they want us to test at alpha equal 0.05 to determine whether or not the amount of candy in the bag is less than 19.25 ounces. All right, once again, I recommend dividing it in four. It's not that you're actually going to stay with it all the way, but it just kind of gives you some guideline as to how much space you need and what to finish this up. So we kind of folded it up into four sections. All right, keeping in mind when they grade the AP exam, your work usually doesn't get you a whole lot of credit. It's the other parts. All right, so here we go. The formula. Well, the formula for a t-test, T equals X bar minus mu S divided by square root of N. Well, immediately I sit there and go, well, what do I have? Well, I know that they claimed that it had to have 19.25 ounces. So I'm going to go ahead and note that down. Mu equals 19.25. My X bar, the sample mean was 19.22. The sample standard deviation was zero point 0.1, and my sample size was 32. So I can go ahead and plug into my formula, and I end up with T equals 19.22 minus 19.25 over zero point 0.1 divided by the square root of 32. I should probably draw a picture of this. My picture is going to look something like this. Well, we always set the population mean in the center. So the mu is 19.25, and we have a X bar of 19.22, and we want to see less than, so we're shading this way. So 19.22, and we're shading this way. All right, I've done everything there. I need to identify the type of test I'm running. Well, because we are using the sample, we already know it's a T because we said it was, but it's because it's a sample standard deviation. So how many samples were there? One sample. The distribution is a T. T-test. And what are we testing? We're testing for means. All right. So I've gone ahead and done that. I'm going to go ahead and write my hypothesis. That's my claim. HO. Mu equals 19.25 because that's what they claim. The alternative, mu and 19.25. Notice this is always equal. The first one will always be equal. I'm going to go ahead and put ounces. 19.25, but this is less than, right? This will always be the same. This will always be the same. The numbers will be the same. The inequality is the only thing that changes. So one sample t-tester means, and there's my hypothesis. We need to define our parameter. So let mu equal the true population mean amount of candy in the bags. In other words, on average, this is what we expect to be in the bags. That's what we were looking for. Well, at this point, we've already set our hypothesis. We've already defined everything. We've actually shown our work, but we need to write our conditions and check everything out for our conditions. So our first conditions, it's got to be a random sample. Well, we know we took a sample of what size? And they didn't tell us it was normal, but we have a random sample of 32. All right. And that was given. So we can just write that down. Random sample of 32 was given. Then we need to check the independence condition, and we'll go, is it too big? Is it too big? So 32 times 10 is 320. But they said that, hey, there is a batch of 5,000. 320 is less than 5,000. The sample size is less than 10% of the population. All right. And then we need to check normality. Well, in this case, they didn't tell us it was normal. We don't know what shape the distribution is, but they took a sample size of 32. So N equals 32, and that's greater than or equal to 30. So we can say the distribution of the means is approximately normal by central limit theorem. All right. So now that we've done all of that and we've set everything up and we showed all our work, we're going to actually run the test. So we go stat, test, t-test. Number 2, the mean, they were claiming 19.25 ounces. Our x-bar, 19.22. Our standard deviation, 0.1 for the sample. Sample size of 32. And we want to know if it was less than, and that's what we showed up here in our graph. So our probability statement, don't forget it, super important. It's a point by itself. The probability that T is less than negative 1.6970 equals 0.0498. All right? Oops. Equals 0.0498. Now we need to make our comparison. P-value, alpha, p-value 0.0498. Oh, we have an alpha of 0.05. 0.05, make them the same length. The p-value is smaller, so we're going to say reject the null. All right? So now we need to write our conclusion. By the way, when it comes to scoring this, typically speaking, the parameter and the conditions are worth 1 point. This next section that we just did, where we actually did the work, is another point. And then finally, the conclusion is a third point. And sometimes they'll ask you for the p-value. So our conclusion, our p-value is 0.0498, which is less than our alpha of 0.05. There should be a comma. Our p-value is 0.0498, which is less than our alpha 0.05. Our decision, we reject the null. When you reject the null, there is plenty of evidence. We have a lot of evidence. There is enough. There is sufficient evidence to suggest that the bags of candy, excuse me, not that the bags of candy, that's wrong, that the true mean weight of candy in the bags is less than 19.25 ounces. I want to take a moment and go back. Well, first off, our p-value is 0.0498, which is less than our alpha 0.05. We reject the null. That's our decision. There's lots of evidence, plenty of evidence to suggest the true mean weight of the candy in the bags is less than 19.25 ounces. I want to make a change to what I wrote earlier about the parameter. When we define the parameter, the true population mean amount, that's probably fine, but I'm going to be more specific and call it the mean weight of candy in the bags because we're really weighing the bags. All right, p-value. P-value is the probability of getting a test statistic this extreme or more extreme given that the null is true. So how would we go about saying that? Well, given that there is actually, given that the true mean weight of candy is 19.25 ounces. There is, what's our probability? There is a 4.98% chance we would get a sample value would get a sample mean of what? What was our sample mean? Our sample mean was 19.22 or less by random chance alone. All right, given the true mean weight of the candy is 19.25 ounces, there is a 4.98% chance that we would get a sample mean of 19.22 or less by random chance alone. All right. All right. I hope that helps and look forward to seeing you on the next one. Thank you for watching.